How's it going, everyone? Elder Gonzalez here again. Right now what you're hearing is my fan, because it's actually getting hot. Summer is here, summer is coming, and yeah, it can be quite a little bit noisy. I know. uh, but I'm gonna try to make this as quick as possible, because in today's video we're going to take a look now at this particular roadmap, which is the way of how now, for example, Navid Deep Sin, which is a software engineer that previously worked at Capital One, Google, interned as in Amazon. So he developed this roadmap as a way to help those developers that want to know how all of these things work, especially computer science, not just technical people, React or Angular or all of these cherry picking frameworks. It's like actually understanding now the fundamentals of this career, which is the computer science, and how you can use all of these particular tools to solve real life problems and develop an awareness of how you can do that, and this pattern recognitions. So by using tools like data structures, algorithm, and techniques, how you can solve most of these common problems. So this roadmap start by first looking at the arrays and hashing, understanding this particular data structure, how you can work with that, what is the most common operation that you can do on that, what is the value proposition of array and hashing, and how you can actually use this data structure to come up with some particular problems. So for example, counting, grouping, and checking as well. So the 2 pointers is a technique that allow us is to identify is when do we need is a pair of elements for a problems. How by using is this algorithm you can a lot of times solve those particular problems. And the other is a stack. This is a data structure. See how you can create your stack. What is the value proposition of stacks as a way to now solve common problems in order. All right. Sliding window, which is another technique. So far we haven't have the opportunity to dive deep here. Linked list, which is a data structure. Binary search, this is an algorithm. And then how you when you combine this as a way to now look at trees, a data structure, tries, heap priority queue, which is something interesting, the problem that you can solve with this, as well as backtracking. And there is also other how do you call it? There are also some other elements that you can dive deep into this, right? So after that you have now tries and backtracking, heap priority queues, graph, UDTP, beam manipulation, or this is dynamic programming, advanced graph, greedy, intervals, math and geometry. As you can see, all of these particular topics. But because in today's video the methodology is that we're gonna take at least the first 10 minutes as a way to solve this, as a way to describe how do we get here, what is the problems that we already solved, all right, and then 20 minutes to think about this particular problem, which is great. And if we couldn't come up with some sort of solutions, understand that how can we solve that by looking at the solution. So first things first, we look at in the array here several problems. I prefer to list them, like contains duplicate, how you can use this data structure called set as a way to now allow you to get only unique values. The only trade-off is that if you pass now an array, it's going to iterate through the entire collections after that, and then solve that. The other is valid anagram as a way to see how you can work now with strings and arrays and sort that in a particular way that you can actually verify and validate that to string, which is great. The other is that to sum. Here is when things starting to make sense when it comes to use a hash for compare, count, and grouping. In this particular case, we use now a hash to compare. If we already have seen that element before, let's take a look now at the complement. Alright? And this is a very interesting exercise here for that. The other is that group anagrams is like how you can make sure that a particular array of a collection of elements here actually belongs to a particular anagram. All right, how he will look at things like sorting and things like sorting or sorting, grouping, but most of the time it's like sorting the string, compare that with that, and then create using a hash as a way to now group all of these anagrams together, right? So by using now not only a hash to compare but also to group as we iterate through these collections, that's how we solve this. This too actually is one of the most interesting problems that you can actually solve, especially by its utility, because after all, top k frequent elements is something that you're gonna do a lot of the time, and there are now particularly algorithms that actually makes you much more to solve those kind of problems much more faster, which is great. Okay. Well, by using is now collections like sorting or exactly by now is taking a look at this array, okay, of the most frequent element, which is a collection of numbers, and then once we sort them, okay, and or in particularly once we iterate through all of these collections and we count the number of occurrence, then how we can now is, give me a second. Okay, so now how can we is as we count the number of occurrence, we can use an array as a way to represent is this, right? Okay. So yeah. So after we count the number of occurrence, we now by having this array or this hashing that contains all of the number of occurrence, we're gonna use now the number of occurrence as a way to represent that into an array where we're gonna put now is those numbers that actually match in that index, or in other words, as the number of occurrence, and then we sort them, all right, and then we take is the most k frequent elements. Or we don't need actually to sort that, right? We just only can say, hey, because we're adding because we have now this array already sorted in an ascending order, because we're gonna add all of these elements as it is, all right? We now for sure that the last elements in there actually contain is the top k frequency. Of course, if there are gaps between each one of those elements, we can actually traverse to the array again as a way to remove all of the or no, there is no need that. There is no need to do that. We just only can get is the most k frequency by sliding this array and get that. Similar to the encode and decode, as a way to see how you can now put some data inside of your string as a way to encode that. And when you need to decode that, how you're gonna read that data to actually extract that out of the string. That's interesting. For product array except self is something quite interesting as well. As a way to have a prefix and a postfix. Valid Sudoku is most likely to see how you can use now matrix as a way to see how you can represent is index in a matrix. Alright. And then we look at the longest consecutive sequence, which is something that we're gonna do today. But as a way to recap other techniques, we look at the valid palindrome, the two-sum input array is sorted, as well as the element that contain with most water. All right. Similar to the stack here. All right. We take a look at the valid parentheses, the mean stack, evaluating reverse Polish notation. That's actually quite interesting. Generate parentheses, but this generate parentheses, anytime you need to generate something, it requires you to have now some greedy or some sort of dynamic programming here. So anytime that is that you need the commute. So anytime you need commutative, but anytime you need permutations of elements, in there you are going to rely on dynamic programming. We also look at daily temperatures, car fleets, and like I said, let's take a look now at the daily temperatures. All right, daily temperatures. And then the sliding window, which is something that we actually saw, which is a particular technique. But let's go into actually solve in today's video a stack problem. All right. We actually solve other particular problems like that, like check if a sentence is a panagram, which is an array and sets. Final duplicate an array. Longest common prefix, we can use this as string and a try for that. And then there you go. You are given okay. Okay. Good. Let's take a look at this. Daily temperature, and let's see if we can actually do this. Okay. Alright. Let's get into this. So today we're gonna do this daily temperature. Day 16. We haven't done this. And what we're doing is just kicking it up. Okay. Longest consecutive array. Day 16 is this one, daily temperature, which is a stack problem. Okay. It's gonna take a look at this. I'm gonna put here the solution, and then the challenge and the count. All right. Roadmap, daily temperature. Here we are. Giving an array of integer temperatures represent the daily temperatures. Return exactly. So giving an array of integer temperatures represent the daily temperatures. Giving an array of integer temperatures represents the daily temperatures. Return an array answer, okay, such that the answer in that position is the number of days you have to wait after the day in that position to get warmer temperatures. The question is that how do we know this? If there is no future day for which this is possible, keep answer this. Keep the answer is equal to 0 instead. Okay. The question is, okay, return an array answer such that the at that day is the number. Okay, return an array answer such that the elements in that array is the number of days you have to wait after the day to get warmer temperature. Okay, so in this case, of course, and this position you have to wait is only 1 because it's next to that. Here you have to wait 1 day. Here in this position, because this is less than because this is less. Okay, let's actually do this something like this. Okay. So we need to generate something called an answer. All right, the answer array. Okay, where here it will have it is value. So if we take a look now at this value here, which is the temperature, okay, which is the temperature here. So the value at this position will represent is the number of days you have to wait after the first day to get warm temperatures. Okay, so in this case, by comparing is this, by doing the brute force, we say, hey, let's go to compare this with this one. It's actually warmer, which is greater. Yes, it is. We have to wait 1 day. The other is in the second position. Hey, here we're gonna see is now the number of days we have to wait after the day in that position to get warm temperatures. And in this case, if we take a look now the next day, it is only 1 because it is more hotter. There you got it. Here at this position we're gonna say, hey, how many days we have to wait until this temperature is get warmer. So we take a look at this. 1, not at all. 2, not at all. 3, not at all. 4 is the number of days we do this. The same for the 69 position, which is that's without any sexual connotations. You have to wait now 1 day at this position. Okay, if we take a look now at the other elements, we have to wait only 1 day. All right. If we take a look now at the second position, we have to wait is 0 day because it's not there. And similar for the last element, which is 0. Okay, so if there is no future day for which this is possible, keep the answer here instead. There's a couple of things here. If the temperature is say 70 today, then in the future a warmer temperature must be either 71, 72, 79, 99 or 100. Because the temperature values is this. We could remember when all them occur next. Okay. Okay. Monolithic stack. monotonic stack. A monotonic stack is a special data structure using algorithm problem solver. Monotonic stack maintaining its elements in either increasing or decreasing order. It is commonly used to efficiently solve problems such as finding the next greater or smaller elements in the array. Okay. A monotonic stack is a common data structure in computer science that maintains its elements in a specific order. Unlike traditional stack, monotonic stack ensure that elements inside the stack are arranged in an increasing or decreasing order. Okay. Monotonic stack ensures that elements inside the stack are arranged in an increasing or decreasing order on their arrival time. In order to achieve the monotonic stack, we have to enforce push and pop operation depending on whether we want monotonic increased stack or monotonic decreasing stack. Let's understand the term monotonic stack here by breaking it down. Monotonic is a word for mathematic function. A function g, which is this, is a monotonic increasing or decreasing when it follows the below conditions. X increase, y also increase always. Then it's a monotonic increasing function or decreasing function. It is a monotonically increasing function, or this one. Similar, a stack is called a monotonic stack if all elements starting from the bottom of the stack is either in increasing or in decreasing order. Because you have to iterate through this. What did you do, man? Oh, okay, hey, stop. Exactly, current element, top of the stack, current element, top of the stack. And then you add that. Okay. Yeah, but the question is that even though the okay, this monotone okay, so one way to do this is because we want to know is the number of days that has passed. Okay. If the temperature is say 17 today, then in the future a warmer temperature must be either 71, 72, 73. Okay. Because we want to return is the number of days, which is by comparing here is this element with all of its elements. This element with the next one until we reach to a particular condition. and then this element with all the subsequent elements as well, and this element with all the subsequent elements as well. The big O notation for that will be is O squared time. Alright. So okay. Okay. Let's take a look at this another example here. But the thing here is that we need to iterate through all of these elements until we find something that matches that condition. You know? And because here we want to know is how many day has passed. Okay, how many day has passed. There is no constraint about here how you can solve this. Okay, I know that the brute force policy here is to iterate through all of these elements and actually compare that. But if this collection is huge, you definitely don't want that. Okay, so what you can do is to go this and compare with the next one until you find that is greater, and then you say, okay, for this position is this one. But if you can see here, all right, since we have to return is an array with the same length, okay, and after all what we want to do is to count if the because what we want to do is to count is the number of position. Okay, we want to count is the number of positions or days that pass onto a condition. Okay. We can use this also as okay. Again, I know my brute force. Okay, I know what to do with my brute force. We define two for loops. One of them is for iterate. One of them is for compare this with the entire collection until we find is the first, and then we're gonna break the second for loops until we find is the first that actually is greater than this, which locally for us is this. And we're gonna do the same for the second element. We're gonna compare with the other elements in there until that number is greater than the rest one, and so on and so forth. So yeah. So for here we can say, hey, I want you to iterate through all of these collections of the temperatures here less or equal Okay, less or equal. Okay, less or equal here temperatures. We're gonna do this until the temperatures dot length is that, and then increment after through. All right, and here we say, hey, I want you to now is say, hey, I'm gonna compare is element, right, or day temperature, which is temperatures and the position. You can say is current day temp. Okay. And then we're gonna iterate through that, which is again this is the brute force. Here we're gonna iterate, but in this case will be is starting from that position plus 1. Okay, we're going to iterate that until that is until you have a next element. All right, for example, you're going to iterate this. So if you have next element, next day temp, all right, if this actually exists, or another way to do this is by using is now a while loop, where you're gonna say, hey, you're gonna do this. Okay, next day is equal to the temperature at that position, and the next one. All right, so I want you to now do this until so while next day exists. All right, hey, I want you to now compare is all of the elements at that position, you know. So I want you to compare is the so if the current day temp is greater than the temperature at that position, which is in this case we can say something like this one, like this one, which is G. All right, so if G exists, all right, if G exists, it will assign this value, and this value is undefined, and not going to throw that, and it will eventually break that, right? Okay, so the idea here is that it's going to compare this. Okay, if the current temperature is greater than the temperature at that position, all right, it means that it is time for us to define is the result or the answer. Okay, so answer here is an empty array, and we say, hey, we want is to now count the number of position that has passed. right? So how can we do that? Well, by taking out the graders and subtract with the minus, and then the difference here, it is actually is that. So you get now is the answer will be is, well, I'm going to update is the answer here by saying is the number of day, which is, hey, math dot bring me the max value, or bring me the difference, because after all I want to know is the difference, and the absolute value of the g minus I. So this is the value that we're going to store now at that position, which is I, right? So for that particular day is this one. If it doesn't exist, well, is this one, and then we're gonna break here, right? So break. If that actually, after we iterate through the entire collection, hey, we couldn't find that, okay, so it means that the answer at that position here is 0. All right, hey, we couldn't find any days warmer, okay. And we need also is to after that is to update this one, okay. You're gonna do this, and after the g will be less than temperatures dot length, okay. That's right. That's what you're gonna do. Hey, if there is a next day, and if the g is actually less than temperature length, you're gonna do this over and over and over, right? Good. And on each new iteration, we're going to increment that until there. So what we're gonna do is to return now the answer for that. Again, this is the brute force solution, right? This is the brute force solution. What is this? Oh, because of course you can reassign these accounts. You got it. You're right. You're absolutely right. What? Oh, it's or. Exactly, because it's or. It's given the condition there. As you can see, it say, hey, not a. I know what you're doing, but no. Your solution is taking too long. So, how can we improve this? Alright? How can we actually now, instead of doing this brute force solution, we can say, hey, I want you to iterate through all of these elements, but as we do that, we want is to now improve the solution. So, let's take a look at how it actually solved that problem.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve a problem, daily temperatures. We're just given an array of integers which represent temperatures, and we want to return an array answer such that at every single position in answer, it's going to be the same exact size as our temperatures array, and at every single position in answer, we want to know for the ith day, whatever the temperature was on the ith day, we want to find how many days did it take for us to find a temperature that was greater than the temperature on the ith day. So for example, let's take a look at this temperatures array. We can see there's 8 values in the temperatures array, and there's 8 values in the output for each value in the temperatures array. For example, 73. How many days did it take us in this array to the right of 73? How many days did it take us to find a new temperature that was greater than 73? Well, on the exact next day, we found 74, which is greater than 73, so it took us 1 day. So in the first position, we're going to return a 1. What about 74? How many days did it take us to find a new temperature that was greater than it? 75, 1 day later, right? Okay, for 75, how many days did it take us? 71 is not greater, 69 is not greater, 72 is not greater, but 76 is greater, and you can see that took about 4 days, right? So then we return a 4 in that position. Now there are some temperatures that never had a temperature greater than them. Look at these last 2 temperatures. We had a 76, nothing to the right of 76 is greater than it, and of course the last position, 73, there's no temperatures to the right of it in the first place, so nothing was greater than 73 to the right. So for these ones, we're going to return a default value of 0. So we're going to build an output array. Now, looking at the input, what's the brute force way to do it? Of course, we could do an n-squared approach, right? Like for every temperature, we would look through the entire temperature array after it, right? And see, okay, how many days did it take us to find a temperature that was greater than this one, right? And then do the same thing for the next temperature over here. Look through the entire array, see, what's the first day that we could find a greater temperature, and keep doing that. Now, that's going to be big O of n squared time complexity, but there actually is an easier way to do this problem if we use some extra memory. Now let's just iterate through the input array once going to the right, but we do need to know that, for example, we have to remember the previous temperatures that we looked at. So if we, let's say the previous temperature here was a 73, like in the input example, and then the next temperature was a 74. When we get to this position, we have to somehow remember what was the temperature that came before it, right? Now, obviously, we could use a list for that, or in this case, a stack would be more intuitive, because one thing we're going to notice is if we get a temperature greater than it, 74, right, then we're going to say, okay, what was our previous temperature, 73? So this temperature is greater than it, right? So we can keep track of what index this occurred at and what index we're at right now, and say, okay, the difference between these indexes was 1, right? We clearly found a temperature, the first temperature, greater than the 73. So then what are we going to do from our stack? Well, then we don't have to remember this anymore, right? We're going to say, okay, we're going to put a 1 in the output, and we can pop this from our stack, right? So we're going to do stack.pop. So this will be popped from the stack. Now when we get to a 75, the exact same thing is going to happen, right? Clearly we see these temperatures are in increasing order. So we see, okay, 1 day it took us to get a temperature greater than this. We'll put a 1 in the output, pop this from the stack. And if we just had increasing temperatures, that would be really easy for us, right? But it's not always going to happen where we have increasing temperatures. What happens if we had a 72 that came after it? Well, we would look at this 72 and compare it to the top of the stack, say, okay, this is not greater. So we can't pop from the stack, but we're also going to take this value and add it to the stack. So now we're going to have 2 values inside of our stack. And what happens if we got another smaller value, 71, right? So far, for none of these values do they have a temperature to the right of them that's greater, right? So all 3 of these are going to be on the stack. What are we noticing about our stack? It's going to be in monotonic decreasing order, right? This is a type of stack problem that I have solved on this channel a couple times, but this is more of a beginner-friendly monotonic decreasing
Okay, this is a more beginner-friendly monotonic
stack problem. What this means is that our stack is going to be in decreasing order. That's what monotonic means. It's always in decreasing order. Now, technically, what happens if we got another 71 over here, right? Well, in that case, 71 is not greater than this, so all 4 of these would be on our stack currently, right? So it's technically not monotonic decreasing order. It could be equal as well, right? We're noticing it's not strictly decreasing. If 2 values are equal, they're also going to go on the stack. But if we got a greater value, if I got to a 72, right, what am I going to do? Clearly 72 is greater than the top of our stack, so I pop this one, right? But now we have a new value on the top of our stack. This one is our 72 greater than this? It's not. So our stack is like this now. We looked at our stack. We took this guy out. This is no longer in our stack, but these 3 values are in our stack. And still, notice how the stack is still in monotonic decreasing order. It's always going to be the case. What happens if instead of a 72 I had a 73? Then of course we'd still pop this 71, and then we'd also want to pop this 72, because now 73 is greater than 72. We pop this, but it's not the case for this one. But if we change this value to a 74, excuse my bad handwriting over here, but if we change this to a 74, then yes, we are going to pop this one as well. So no matter what we do, our stack is always going to be in monotonic decreasing order. If I add a 70 over here, we're not going to pop anything. It's still in decreasing order. So let's just run through a quick simulation and let me show you how we can get this output in linear time using a stack. So first value 73, we're going to compare it to the top of our stack. Our stack is empty, so we're not going to do anything. We're just going to take this 73, add it to the stack. Next, we're at 74. We're going to compare it to the top of the stack. 74 is greater than 73, right? What index did 73 occur at? At index 0. What index does 74 occur at index 1? So we take the difference, 1 minus 0. So it took us 1 position to find a value greater than 73, so we can pop 73 from our stack, and then 74 is going to be on the top of our stack now. Now exact same thing is going to happen with 75, right? 75 is greater than this. The difference between the indexes is 1, so we add a 1 to the output for 74, and we pop 74. Now we're at, and we add 75 to the stack. Next we get 71. 71 is not greater than the top of our stack, so all we do is add it. We don't update the output in either of those positions. Again, we get a smaller value, 69, so we add it to the stack. We can't pop any of these. 69 is not greater than either of these. Next we get a 72, right? 72 is greater than 69, right? So we pop 69. What was the difference between the indices? It was 1, so we're going to take in the corresponding output position, which is in this position for 69, we're going to say, okay, there was an index difference of 1. Now we're going to look at the next top of our stack, 71. So the difference between these two is 2. So for 71, we're going to say it took 2 days for us to find a greater temperature than 71. So for this position, we add a 2. So we pop 71 from our stack. Now 72 is not greater than 75, so we still have a hole in our output over here. We never found a greater temperature than 75 yet. And similarly for 72, we have a hole. Next, we get 76 and compare it to the top of our stack. So 76 is greater than 72. We pop 72. The difference, the number of days it took us was just 1 day, so we can add a 1 for 72, and then we look at the next top of our stack. Yes, we finally found a temperature greater than 75. It took us 1, 2, 3, 4 days to do that, so we can add a 4 in the output in the corresponding position over here. And we can pop 75 from our stack. I think I just need one more square over here, because we have one last temperature in our input, 73, so we're going to add 73. See, 73 is not greater than 76, so we can't pop that. And now at the end, we have no more temperatures to add, right? We still have 2 temperatures left in our stack, and whatever the default value for the unpopped temperatures is just going to be 0, right? They told us in the description of the problem that if we can't get a greater temperature, we're just going to put 0 for these. So that's how we build the output. You can see it exactly matches the output that they built in the example, and we did that in linear time by using this monotonically decreasing stack in O of n time, O of n memory. So now let's jump into the code. So we are going to have a result or answer array, and it's initially going to be default values of 0 because that's kind of what they tell us, and it's going to be the exact same length as the input array temperatures. I'm also going to have a stack. Remember, this is our extra memory. It's going to contain a pair of values. In the drawing example, I only showed that we're adding the temperature, but we're also going to add the index of the temperature so we can calculate the difference, basically calculate the number of days it took us to find a greater temperature. So we're going to be adding two values to this stack, a pair of temperature and the index that that temperature occurred at. Next, we're just going to iterate through the temperatures array. We're going to enumerate this, meaning we're going to get the index of it and the value at the same time. It just makes the code a little bit cleaner. I is the index, T is the temperature. First thing we're going to do is see, is our stack empty? And if it is this temperature greater than the temperature on the top of our stack? The top of our stack is index -1 in Python, and the temperature is the first value in that pair, so index 0. And so if this is true, of course we can pop from our stack, right? So stack.pop, so I'm going to call it the stack temperature and the stack index, which we just popped, right? And for this temperature, we want to, in the result output, say, okay, whatever the index of this temperature was, stack index, we want to compute the number of days it took us to find a greater temperature. We can do that with I, the current temperature that we're at, minus the index of the temperature that we just popped, and we take the difference of those. That gives us the number of days it took to find a greater temperature, and then we're just adding it to the stack at the corresponding position we want to. And then once that while loop is done, it might execute 0 times, it might execute multiple times. After it's done, then we finally want to append to the stack the temperature that we're currently traversing. So a pair, the T, the temperature value, and the index of that temperature. And once we're done with that, we can go ahead and return our result. The reason we don't have to fill in any extra zeros if our stack is non-empty is because we already initialized our result to be 0. So if we never filled anything in, the default value is automatically going to be 0. So you can see the solution works and is pretty efficient. So I hope this was helpful. If it was, please like and subscribe.
God damn it. Okay. Holy moly. What? Jesus. Holy moly. Alright, exactly.
Do is C index. We want to and then once that while loop is done, it might execute 0 times, it might execute multiple times. After it
This is like quite overkill, man. quite overkill. Oh, it's because it's this one. Exactly. So for the next position, if the next day exists, alright, it means that we can iterate through that, right? However, if next day doesn't exist, what we're gonna do is just, if that, let's going to iterate through all of the next elements there and see if you actually now have if a data whose temperature is greater than the current. If you find that, well, actually what you're gonna do is to put the difference in there, in their index, and then break. If you couldn't find any next day, so it means that, well, exactly. If you couldn't find any days there, okay. If you couldn't find any days there, all we can say is this will be is now an array of, and fill it with 0. Say, hey, the length of this will be is the temperature dot length, where now I want you to fill all of them with 0 initially. So when you run this, it's a declaration of statement expected. Oh, of course. There you got it. Answer at that position. Well, you want is to actually add that value there. Exactly. You want to add that value and that position there. I mean, is this one. Exactly. Is this one. Wait, what? There was a connectivity issue there. And then you got it. Again, this actually worked, but this is in worst cases in it. This is in worst cases in exact time limit exceed. Of course, worst cases in error. Worst cases in error. Exactly. You pass a huge collection and that time exceed. You know, it doesn't matter. But at least it's starting to see that the flow of your thinking, and that's something good. So with that, that'll be all for this video. Take care. Bye bye.